as traffic fragmentation, traffic substitution, and encryption. Just to name a few, it is the responsibility of a security analyst to understand how attacker can use these methods to evade the IPS system and gain access to the network. Traffic fragmentation was one of the earliest IPS evasion techniques used by attacker to evade IPS system. The attacker would send fragmented traffic to the network in the hopes that the IPS system was not performing fragmentation reassembly or reordering the fragment as they enter the IPS in the wrong order. The attacker would fragment all IPF traffic, hoping that the IPS would not reorder or perform reassembly on the traffic. The attacker were also known to send the fragmented traffic in a manner that is not uniquely interpreted, causing the IPS sensor to interpret it differently from the target. In addition to the classic fragmentation attacks, there have been many variations of the fragmentation attack, where the fragments overlap and the offset value in the IP header don't match up. Different operating systems manage the situation differently, and the IPS sensor really may not know how the target system will reassemble the packets. Excuse me. In the example, the F1 fragment is received normally, but the offset in the second fragment F2 overwrites the JPEG part of the first fragment. The target system prefers data from a later fragment and reassemble the packet to obtain the payload string cmd.exe, and it attempts to execute command. The IPS sensor does not reassemble the overlapping fragment in the same manner that the fragment system does and misses the attack. The IPS sensor prefers the data from the first fragment and reassemble the payload as non-threatening command.jpg. Another evasion technique is the substitution and insertion method. This is where the attacker substitutes the payload data with other data in different formats that mean the same thing. The IPS sensors might not recognize the signature of the data and miss the threat. Some of the substitutions might be Unicode representation instead of HTTP request, changing the case of character to evade case-sensitive signature in the IPS, and substituting spaces for tabs and vice versa. Let's look at another example, and you will see there that the string CGI bin in a URL has been encoded as a string of character. You see here where C is C, G is G, and I is I, and so on until the entire string is replaced with Unicode. Another common attack that hacker used to evade IPS system is called the encryption and tunneling attack. In this attack, the IPS is expecting the transmitted data in clear text and it is encrypted. Since the traffic is encrypted, the IPS can't inspect the data and assume the attacker already has an established and encrypted connection to the target, such as a VPN tunnel. Often the hacker can tunnel their traffic over protocols that normally are permitted, such as DNS and HTTP. Attacker can also try to evade detection by causing IPS sensor to misinterpret the end-to-end meaning of network protocols and see traffic different from the target in a protocol level misinterpretation attack. The attacker could intentionally corrupt the TCP checksum of specific packet to confuse the IPS sensor that doesn't validate the TCP checksum. And there is the bull in the China shop type attack, where the attacker flood the IPS with tons of bogus traffic to produce smoke screen or noise. If the IPS is busy with the noise, the true attack traffic might have chance of slipping by. This type of attack is called the resource